Hi, my name is Darshan and I'm an online tutor of math and physics. This video is on FRQ number 3 of EP Precalculus, the sample exam which is released by College Board on its website. It's an interesting one based on sinusoidal curve. So let's read this one. By the way, calculator is not allowed. So this is from part B. The blades of an electric fan rotate in a clockwise direction and complete 5 rotations every second. Point B is on the tip of one of the fan blades and is located directly above the center of the fan at t equal to 0 seconds. So this is the point B, and from the center its distance is located, as indicated in the figure. Point B is 6 inches from the center of the fan. So from the center of the fan it is 6 inches above, and the center of the fan itself is 20 inches above the level table where the fan sits. So in other words, this distance is being given to us as 20 inches, and from the center to the tip it's given as 6 inches. Okay, as the fan rotates at a constant speed, that is the key word, the speed is constant over here, the distance between B and the surface of the table periodically decreases and increases, which definitely makes sense, right? Because B comes here, decreases, the height decreases, then the height becomes minimum, then the height increases, then height becomes maximum, and so on and so forth. So the sinusoidal function models the distance between B and the surface of the table in inches over the period of time in seconds. Now the graph of h as in the height of that point from the ground, and its dashed middle line for full cycles is shown. So these are 2 full cycles, and this dashed line is the midline. They have not given any scale, they have not given any axis, but we have to determine the possible coordinates of f, g, j, k, and p. F, g, j, k, and p. What are the possible coordinates? So even though the axis is not given, we are for sure that if that point is on the maximum, definitely that point must have been 26 units from the ground, because from the ground the maximum point is obviously 26 units. I hope you agree with me. So I can definitely say that whatever is its x coordinate is, I do not know, but its y coordinate must be 26 and its y coordinate must be 26. We are yet to figure out the x coordinate. And j is the minimum value, which means that the point must have been over here at that point. So what will be the distance from the ground? Obviously from the ground it is going to be, if we notice carefully, this is also 6 units. So I mean, I hope you understand what I'm trying to say over here. I'll just redraw it separately so that you get a sense of it. Okay, what I'm trying to say is, okay, this looks quite uneven, so let me increase the length. Okay, what I'm trying to say is, this is the center, this length is 6, this length is also 6, and this complete length is 20. So obviously this length, which is the minimum length, is going to be 20 minus 6, correct? And what is 20 minus 6? That's 14. So this, again, I do not know the x coordinate, but I'm very sure that the y coordinate is 14 over here. And finally, this is the midpoint of it, right? So midpoint means the point is somewhere over here, which is exactly at 20, right? So for G, y coordinate is 20, and for K, y coordinate is also 20. Now we're going to work on the x coordinates. Now at t equal to 0, where is the point? Don't you think the point is actually at the top? So I can say that f could potentially denote the situation which is indicated, which is point B, because they are asking for possible coordinates, right? So possibility for f to be as what is shown in the image to us. So I'll say that this time is 0. Now it's quite easy to find the other times, because now we have to use this property that it completes 5 rotations in 1 second. So what is the time period of it? Time period means what is the time taken for one complete rotation? For 5 rotation, it is taking 1 second. 5 rotation, it is taking 1 second. So can I say 5 over 1 is the proportion? And we need 1 rotation. So 1 rotation will take how much time? Let's say it's t. So this proportion is obviously equal So if we cross multiply, then 5t is equal to 1, which means that t is 1/5 or t is 0.2 seconds. This is the time period. It is the time taken for one complete revolution. And it makes sense, right? Like uh, 5 rotation in just 1 second. So how many seconds will it take for one rotation? You just, sort of take 1/5 on both the sides. 5 is 1. So 1 is 1/5. So it's 0.2. So if it is 0.2, can I say that this point P will once again come after 0.2 seconds, because this has completed one complete period from here to here. So obviously P must have been at 0.2. And can I say that J must have been at half the period, because it is exactly at the middle. So this should have been over at half, which is 0.2 over 2 is 0.1. And what is the midpoint of 0 and 0.1? Because notice carefully, this is right at the middle. So obviously it should have moved symmetrically, right? So this would have been 0.1 over 2, and 0.1 over 2 is 0.05. So this will be 0.05, 0.05 and 20. And likewise, this will be the middle point of the midpoint of 0.1 and 0.2, which is 0.15. So this will be 0.15, comma 20. This is the case over here. So these are all the possible 5 points which we can have in part A. Hope that makes sense. In part B, we're asking us to find, write the equation and obviously the trigonometric form, which is this, and find the constants A, B, C, D. Okay, we can do that. Okay, now h of t is given by a sine b t plus c plus d. There are some a couple of things which we should know about for trigonometry. Whenever we write anything in this form, this d represents the midline, right? And what is the midline, by the way? If you go back, midline is 20. So if the midline is 20 over here, so I will say that the value of d is also 20. And then the value of a is very easy to find, because a is the amplitude, the distance of the midline to the top, or the distance of the midline to the bottom. If I go back, the distance of the midline to the top is 6 units, and the distance of the midline to the bottom is also 6 units. It means that the amplitude A, because A defines amplitude A is 6 units. So I'm going to write 6 over here. And then I have to find B. So B, there's a direct formula that whatever this guy is, it is actually equal to 2 pi over the time period. And we already got time period in the previous slides, which was 0.5. It was 0.5, right? Oh, sorry, my bad, 0.2. So it should be 0.2 over here. And what is 2 pi over 0.2? I think 0.2 is what, 1/5, so 5 times 2 is 10. So B is 10 pi. And finally, we have to find the value of C. So for C, we can do a little effort. Let's first write whatever we have till now. We have A, B, and D already. So the value of the equation of H, which we have till this point, is going to be 6 sine 10 pi t plus C plus D, which is 20. And now I just need an initial condition, to find the value of C, because I know that at t equal to 0, at when it was starting, the H was maximum, which was 26. So can I say that at t equal to 0, H was 26, because you can clearly see that this point is on over here as well. So I'm just using it to find the value of C. So this becomes 26 is equal to 6 times sine of 10 pi times 0 plus C plus 20. Subtracting 20 both the sides, then 26 minus 20 is just 6. So 6 is equal to 6 sine of 10 pi C. 6 and 6 is gone from both the sides, so 1 is equal to sine of 10 pi C. I'm going to need some space over here. Let me move these things over on the right, and let me separate my work over here, perhaps with a different color. Okay. So when is sine 1? Sine is 1 when the angle is pi over 2, right? So I will say that 10 pi c should be equal to pi over 2. Pi and pi is gone, so it means that the value of c should be 1 over 20. And what is 1 over 20? That is 0.05. So that is the value of c, and all we have to do is plug in the c as well over here. So this ht, or I'm just going to write h, is equal to 6 sine 10 pi t plus 0.05 plus 20. Running a little short in space here. Plus 20. Plus 20. This is the final equation, and these are the corresponding values of a, b, c, and d as well. Hope that makes sense. Let's work on the next question. Referring to the graph of h in part A, I'll just pull that graph once again so that we don't have to toggle the slides again and again. This is the graph. They are saying that between T1 and T2, and what is T1? T1 is the point K. This is T1. And what is T2? T2 is the point P. So they are asking that which of the following is true about H? H is positive, increasing, positive decreasing, negative increasing, negative decreasing. So that is for sure that h is positive, right? I mean, height is always positive because the maximum value of height is 26 and the minimum value is 14. So height is always positive. There is no doubt in that. And clearly height is also increasing, right? Because you can clearly see, it's pretty much evident that with the increase of the x value, the value of y is also increasing. So height is increasing. That is for sure. So the answer will be part A, which is the height is positive and it's increasing as well. Part 2 is interesting because they're asking that describe how the rate of change of h is changing on the interval t1 to t2. Describe how the rate of change of h is changing from h1 to h2. It means that they're asking whether the slope of the tangent made between this region, that slope is increasing or decreasing. Now, if you notice carefully, if we draw a tangent like right over here, near the point K, the tangent is going to look like this. And if we draw a tangent near to P, the tangent is going to look a little bit more flat. So you will agree that the tangent is going like this. So can we also agree that this is more steep, and as it moves from K to P, the steepness decreases? And the steepness decreases. If the steepness decreases, it means that the slope of the tangent decreases. It means that the rate of change also decreases. Another way to think about this is a concave down function. And in concave down function, the rate of change always decreases. In a concave up function, the rate of change increases. So either you can visualize it the way I explained, or you can just say that, okay, this is a concave down function. For a concave down function, the rate of change always decreases, and hence the answer is it decreases. Yeah, it was a really good question. Someone requested me to make a video on this, so I'm just making this up. I hope that makes sense. If there's any question, please feel free to post it down in the comment section. I'll see you soon with another video. Bye-bye.